Thank you. Great to see all of you. Okay. Well, hello, everybody. Great to see all of you. Really good to be back in person, right? And I was actually just at a DevOps Days last week in Birmingham, Alabama, in the United States. A little bit different than Aarhus, Denmark. But, you know, a lot of the same type of people, thinking about the same type of things. How can we make developers more productive? How can we make software organizations more innovative in 2022? So we're going to talk about one way that we could do that today. I am Justin Reock, Chief Evangelist, Field CTO at Gradle. My background is primarily in software development. I wrote code for a long time and then moved into more of enterprise architecture work, working with a lot of open source software, which actually ended up taking me to Gradle. And the interesting thing about open source and its ability to sort of remove friction and bottlenecks for developers to be able to do their job is that it really is more about productivity, if you think about it. It's never been too interesting that open source is like free as in free beer, right? It's the free as in free speech aspect. But that really unlocks all types of doors for developers. So it was very natural for me to move from a position of sort of evangelizing the enterprise use of open source to now enterprise adoption of what we're calling developer productivity engineering. So I think it all really starts here. And that is that software development is fundamentally a creative process. Okay, it's also a scientific process, but it's very rewarding when the feedback cycles are smooth and when the hypothesis that we make with the computer yields a result very quickly. So these kids are figuring out programming. Maybe some of us felt this way the first time that we got a Hello World application running, right? And the feedback was pretty much instant, right? We put in whatever it was, system out, println, hello world. We ran the command, it came out, it works. And these kids are experiencing that kind of moment right now. Now, what kind of moment do you think they'd be experiencing if their Hello World program took 45 minutes or an hour to build, or run a test cycle that took hours after that? You're not going to look like that at all. You're not going to be in a state of creative flow, ecstatic with the work coming out. You're going to be frustrated. You're going to be experiencing toil and friction. And we can't do this anymore. All right? It's not about Hello World programs. In 2020 of October, IDC predicted that by now, roughly 65% of the global GDP would be digitally transformed. And it happened. They were right. COVID definitely accelerated that a little bit, but the pace is continuing to increase. Let that sink in for a minute. 65% of the global GDP, which suddenly, like, that can't be possible. What about agriculture product? Well, the data being collected by the actual farming equipment that's used to harvest our food and agriculture product is just as important now because of the predictive models that we're able to build from that, okay? So that's a lot of code, right? And we don't have enough developers to meet the need. And software is lifting every industry. This was just published a couple of months ago. The work was actually completed back in June of last year. Anybody familiar with the fact that we finally decoded the remaining 8% of the human genome this year? And it was done as a result, accelerated as a result of deep neural network technology and Slack. The whole thing was collaborated on via Slack, okay? What happens when an advancement happens in one place in computing? We end up with, potentially, the ability to build a predictive model about our own DNA that can tell us with some certainty where the next novel pathogen might arise on the planet and what vaccine we should print years before it even shows up in the wild, all right? It's one possibility of what software is able to do for this world. And the best code is written by happy developers. So if we want to live in a high-quality world that's powered by software, and we want to solve the biggest challenges, then we need to make sure that we're taking care of our developers. We need to make sure that they're not experiencing hour-long build times. We need to make sure that they're not experiencing tons of friction and pain when they're just trying to troubleshoot something with a build. Right? If we have the ability to avoid them running into flaky tests, why shouldn't we do that? It's 2022. So instead of taking care of developers the way that we should, enterprise software development is instead creating a whole unique set of challenges. Ironically, as enterprise software becomes more successful, the developer experience worsens, right? More dependencies, more lines of code, more developers involved, the repository grows, and the build times and the test cycle times grow with it, right? The experience that the developer has working on that project becomes worse and worse and worse as that project becomes more and more successful. And it's no longer the big beating the small, but the fast beating the slow. Okay, this is the rallying cry of DevOps, right? This quote is known. It's been around for years. It's based in constraints-based thinking. For those who are familiar with the theory of constraints and the goal and all that, that it's no longer big companies beating the small ones, right? It's the fast, innovative companies that can create a lot of throughput and get their code out to customers, making money faster. So why is this the average calendar of our developer? Why do they wake up in the morning, fresh, ready to go? We're going to write some code, and then we spend the rest of that morning waiting for our local build time to complete, and then debugging a local build failure. All right, that sounds like a lot of fun. We're going to do that, and then we're going to go to lunch. We're going to come back, we're going to code some more. Yay, we're in creative flow. We're going to wait for our local build to complete, and it works this time. We successfully troubleshooted it, so we're going to kick it off to CI, and tests are going to be flaky, and we're going to spend the rest of the day debugging flaky tests. All right, we can definitely do better than this. And this isn't just speculation. All right, Gradle ran a study with a bunch of folks who are using our own developer productivity engineering solution, found that 92% of them complained about too much time waiting on build and test feedback either locally or during CI. Right? And then the next set was just not having the right types of tools to be able to troubleshoot problems when they were actually encountered, including things like CI failures and flaky tests. So it's for this reason that I think we can make a pretty clear-eyed statement that developer productivity engineering, the techniques and thought process that we're about to talk about here, is the next big thing in software development after DevOps. And I don't mean that that developer productivity engineering is something that's only for DevOps mature organizations or something that's for Silicon Valley companies. I don't mean it that way. I mean really that the consciousness of the industry is shifting towards developer productivity, right? And it's new. Netflix just started their developer productivity team in 2018. Right? LinkedIn was in 2017, right before that. They actually built a developer productivity team at LinkedIn. But this is all relatively new, okay? And you have the ability now to learn a discipline that I think will be as important as DevOps, as more and more of the industry starts realizing that to vertically scale an organization, we have to make our developers more productive, and there are engineering solutions for this. So that's really the essence of developer productivity engineering. For all of that theory, it's pretty straightforward, right? We're going to use engineering techniques, acceleration technology, observability technology, and analytics to try to engineer a better developer experience, right? We're going to try to put technologies in place that will decrease build and test cycle times for developers. We're going to try to give them tools that make it easier to troubleshoot builds and collaborate on that with other people who are in their organization. We're just going to look at these bottlenecks that still exist, and we're going to engineer our way around them, okay? Hence developer productivity engineering. What it is not, it's not what we would consider like traditional developer productivity management solutions, all right, which might focus on people or looking at metrics like lines of code and things like that don't really matter. Instead, we focus on the process and the technology, right? We're looking specifically for system bottlenecks. We're looking specifically for friction and toil in the build tool chain that we can improve. So the metrics then are basically, they're based on outcomes as opposed to increased activity. So an increased team velocity, if you happen to be an agile organization. Because of that, the SDLC focus right now is mostly on build and test, mostly still on CI, because we're focused on the developer experience, right? This really is trying to attack just the bottlenecks that still exist in the process of actually writing code. Okay, but this may change, right? We already know that developers are starting to work with systems where their code ends up in production 15 seconds later through some crazy, service mesh canary release where 1 out of 1 million users are seeing it for 5 seconds or whatever. And if we get there, then we'll have to start, accounting for that as well. And the ROI of taking on a developer productivity engineering transformation in your business is hard and proven, right? You're clearing bottlenecks. You're saying the local build times for developers took 45 minutes. Now they took 5 minutes. We have 100 developers. We do 100,000 builds a week. You do the math. Okay? Really quick, how many people are actually tracking local build times? Wow, just a few of you. Kind of amazing, right? Like, why don't we think about this stuff? Like, we're tracking so much stuff in production, right? We look at every metric we can think of. And our release metrics, too, things like commit to deploy or whatever, we're looking at all those. Why aren't we just tracking what developers are experiencing in their workstations? It's a good question. When my boss, Hans Doctor, some of you may know him as the inventor of Gradle, sold our technology to BMW a few years ago, his pitch was kind of straightforward. He went to them and said, hey, are you tracking local build times? And they said, no, we're not. He said, well, what happened if I went to your production factory and told them that this metric was missing? He said, oh my God, they'd be really mad at us. And again, I just think it's part of a consciousness that we're just not woken up to as an industry. We haven't been thinking about this. It's just been kind of an occupational hazard of writing code that you have to deal with this type of toil, right? But we're saying it really doesn't have to be that way. The outcomes of this, when you bring this into your organization, are felt at all levels. This is where you really have an opportunity to be a hero. If you can imagine if you were the person that brought DevOps into your organization 5 years ago, 10 years ago, what does that do for your career path, right? And developer productivity engineering has the same possibility to create that kind of career path for you and create value at every level of the organization. Starting at the bottom, just developer build engineering pains. So slow builds and feedback cycles and inefficient troubleshooting, which bubbles up into a better time to market for VP levels, more productivity, and ultimately a better quality of service. And then that bubbles all the way up to the C-level objectives of revenue, cost, and brand, right? This, again, going back to theory of constraints, is absolutely a process meant to increase the throughput of a business while decreasing its cost. And if anybody's read the goal or organizational physics or anything like that, physics pretty much denotes that that's going to be a winning strategy for your organization. So to be really clear, what are we solving? So if you can imagine, we've got our developer over here in a local environment at their local workstation, or even in a remote workstation environment, like there are some organizations, like if you look at Meta or Facebook's massive monorepo, they've got almost 4 gigs of code in their monorepo. So just trying to pull that thing down and starting to work on it's impossible. They use nothing but remote environments to do that. And then, of course, CI environments. It's been very popular for more powerful cloud-based CI environments for developers to kick off test cycles or build cycles into those environments as well. So what happens? Well, sometimes it's fine, right? So you see these feedback cycles that, is that a laser pointer? No. Feedback cycles that, are not, they're smooth, they're okay. But sometimes the feedback cycle just takes too long. All right, going back to the hour-long plus build cycle. We actually had one customer, almost 20 hours for a single clean build process. Takes too long to fix. All right, something broke, and I don't have the right observability. I don't have the right collaboration tools to try to fix this problem efficiently. I'm copying and pasting crap from the console log and the environment and Linux output into Slack, trying to get to the bottom of what actually broke in this thing. And then the worst one, the one that really keeps me up, could have been prevented, right? Something that the developer's facing, a problem that they're facing that could have been avoided if we had proactively done things like measured all common failures happening across a developer organization, or actually proactively looking for flaky tests and then eliminating them, right? So problems that could have been avoided, those are the worst. 81% of the same surveyed IT professionals said the DPE made their job more enjoyable. And should be pretty straightforward, right? I mean, going back to the kids at the beginning, going back to the idea that writing code is both a creative and scientific process. The brain has actually been mapped. Like they've done this. They've done brain mapping watching developers write code. And it's left brain activity, right brain activity going on. I mean, anybody who's done this, you know what it feels like. You know what that state of flow feels like. So to be able to have a tool chain that keeps you in that state of creative flow more often, in that sort of ecstatic work mode where time sort of disappears, then of course you're going to be happier in your work. Why wouldn't you be? So the pillars of developer productivity engineering then really focus on these more acute and then chronic pains of an organization. Starting with idle wait time, I think we've talked a lot about that. What do we do in terms of technology for dealing with this problem? We actually have 3 bits of technology that we recommend that you look at right now. This is vendor, meant to be sort of vendor agnostic. These technologies exist in a lot of different forms. Idle wait time, what do we want? We want faster feedback cycles for developers. Okay, what do we recommend? Build caches. Anyone familiar with Gradle's build cache or Bazel's build cache? Yeah? So build caches are there to provide like incremental task level caching for your build. We'll go into that a little bit. Test distribution. This is where we try to come up with a consumer fan-out pattern for unit tests, or really any type of test, browser tests, integration tests, even if we need to. And then predictive test selection, which is brand new to my organization, published in a paper by Facebook in 2019. We'll talk a little bit about it. This is using a machine learning model to track change history and say when similar changes were made to source, did this result in something interesting happening to the test? Like, did it change its status as a result? And if so, maybe we should only run the tests that are actually going to produce some interesting feedback. So that's our first part, faster feedback cycles. And what about faster troubleshooting? Well, we just need better, more collaborative, and more observable tools for allowing build engineers and developers to troubleshoot together. Anybody familiar with the Gradle build scan? That's also part of the free open source Gradle build tool. Anybody can run one of those right now? That's one example of what we would recommend that you do for having something shareable that really tracks every aspect of the build, that's not forcing your developers to, again, copy and paste console log output, Jenkins output, Linux output, whatever, pile it all into Slack. How about reliable builds and tests? How can we not have developers have to deal with flaky tests and other avoidable failures? We just recommend tracking this, right, across all of your builds in the organization. Track the build failures that your developers are running into. You're going to find out some interesting stuff, especially with larger development teams. You're going to find out that a lot of these developers are dealing with the same failures, and that those failures are taking a certain amount of time to actually reach in the build, so that's just wasted time, and they have to go troubleshoot it. But these are common failures that could actually be resolved centrally if somebody was looking at this. And the same is true with flaky tests. So our Gradle build tool team and our Gradle enterprise team, they schedule flaky test days. Pretty simple. Like every month, they just open up their dashboard where they've got all the flaky tests that have been detected in the builds over the last month, and they just go down the list, start solving the flakiest tests first, and then developers don't have to deal with those. So an example of how we can use data to get rid of sort of avoidable failures. Okay, very fast feedback cycles are important. Why? Well, they have a cascading effect on the entire organization. If we start with faster feedback cycles for developers on the left here, then a few things are going to happen. On the bottom, we'll see that developers build more often. All right, that's a big deal. Smaller change sets at once, right? Not trying to cram a whole bunch of code into a single build because got to wait a long time to see if what you did was right. But no, being able to build more frequently, being able to ask the computer for feedback more frequently, being able to refine your work, okay? That leads to early quality checks, smaller change sets, more efficient troubleshooting, fewer merge conflicts, and then fewer expensive downstream incidents, all leading to faster mean time to resolve, bubbling up to quality. And then on the top, we've talked about this a lot already, but just the less idle wait time means less context switching for developers, less forcing them to change what they're doing. We'll look at some numbers here, talking about how hour-long builds. Obviously, developers don't just sit there twiddling their thumbs for an hour. It's usually go get a coffee or something like that, right? But even then, in that hour, 10 to 15 minutes is the general cost of a context switch, sometimes 20 depending, right? So how much of that hour is going to really be productive? Not that much. And we're also finding out that this context switching and multitasking isn't just sort of impossible for the human mind, it's actually deleterious. It's actually bad for executive brain functioning. So we're trying to eliminate that as well to give us more focused developers and, again, improving our productivity and quality. So much starts with faster feedback cycles for developers. To look at some kind of thought experiment math here, take a team of 11 developers with a 4-minute build time. 2 stories are told by this slide, and I'll explain that in a moment. Let's say in a unit of time, maybe a day, this one team of 11 developers is able to produce 850 builds a day, right? They're asking for feedback roughly 850 times. Okay, not bad. But take a team of 6, a smaller team, with a 1-minute build as opposed to a 4-minute build. In this same period of time, if you run the math, they're actually going to be able to run almost 200 more builds. They're going to be able to ask for feedback more often. This is a smaller team. So this slide really tells 2 stories. First of all, if you ask a lot of people if a 4-minute build time is a problem, they'd be like, no, that sounds great. I would love a 4-minute build time, right? But look at the impact that going from 4 minutes to 1 minute can take. And then look at the efficiency that you can increase in a smaller organization in terms of how often they're able to refine their work. Now, scale this one out. Even a 1-minute build time down to 0.6 minutes for that small team of 6 developers returns 44 days of engineering value a year to that team. For a team of 6, that's huge, okay? And that's just going from 1 minute, again, sounds great, to 0.6 minutes. And how about this 100 developers with 12,000 builds a week, taking a 9-minute build time, not great, but certainly not horrific, down to 5 minutes, 5,200 days of engineering value a year is returned to this organization. So this is why we have to change our mindset fundamentally. We can't ask the question, is the build fast enough? We have to ask, is it as fast as it can possibly be, given all acceleration technologies and observability? Because that's what our developers deserve, right? That's the investment that we need to make. Okay, so build caching. That's one of the acceleration technologies that we mentioned. It was introduced to the Java world by the Gradle open source tool in 2017, and it's used by leading technology companies like Google and Facebook. Gradle is not the only build tool with a build cache. Bazel famously has one as well. We've enabled one for Maven in Gradle Enterprise. And can support both user local and remote caching for distributed teams. Build caches are not dependency caches. Right, so we're not talking about like a JFrog, Artifactory, Sonatype Nexus that's holding our dependencies for us. Build caches are literally taking steps, phases of the build, storing the inputs to those phases against a cryptographic key in a cache, and storing the outputs of that phase of the build. So compiled classes or whatever actually could be stitched together to form a full assembled package. And then we can skip that work even in a clean build. Pretty straightforward with the way that it works for Gradle. Gradle tasks are Maven goal executions. We again look at the inputs. Those inputs there's a lot. There's source code, there's JVM information, there's environment information, there's stuff around the operating system. So it's actually a really elegant solution when you look at all the different pieces that form that input. Elegant in that I could create that cache entry against a key. 2 years later, somebody could build under the exact same conditions and still safely pull from cache because of the way that the key caching works. So when the inputs haven't changed, the outputs can be reused from a previous run. If you're familiar with like Gradle up-to-date incremental task building, this is different. This is actually what allow you to take advantage of caching during a clean build, first build of the day, whatever you want to call it. So this is the first bit of technology that we really recommend. Look into caching parts of your build. And then speed up troubleshooting with a build scan. Again, you can run a Gradle build scan for free right now. It's part of the open source tool. If you do a Gradle build -- scan, it'll pull it up. You can take a good look at what we're talking about. It's also available for Maven. Go to scans.gradle.com and you can check it out if you're interested. But this isn't a product pitch. This really is more of an appeal to look at this stuff yourself, right? To try to gather this data during a failure, right? It's all there. It's not hard to scrape, right? Just pull things like the console log, any failures that happened, switches, like configuration switches in your build tool, environment details like heap size and version of whatever, if you're using Java, the version of the JDK. Details that would normally have to be sussed from multiple different places and then, back and forth asking questions. Just suck it all down as part of CI or part of the build and make that available in a shareable format. For people to collaborate with. Test distribution can make tests even faster. So, thank you. With test distribution, again, if you look at the progression here, we're caching to try to avoid tasks in the build. Those would include test tasks, right? You'll see in a moment that we also have a machine learning technology that we recommend, predictive test selection, which I'll tell you about in a second. But any work that still has to be done, we recommend that you just distribute it using a consumer fan-out pattern, right? Anything that has test execution available via an API will allow you to do this. So any of the JUnit 5 platform stuff, or even the vintage 4.3, and of course there's plenty of other platforms that will allow you to control test execution using an API. If you can do that, then you can distribute the tests, right? For us, it just means actually a very small test runner that lives in a Docker container, and then we have some basically like Helm charts that can throw that into Kubernetes, and we've got a nice KeyEDA autoscaler that goes with it, right? But those patterns, most of that scale comes from Kubernetes, right? Our agents are actually pretty small, so these aren't too hard to build. And then kind of to wrap things up, the last part of this is in the observability. So we've looked at acceleration technologies, we've looked at better troubleshooting, right? Less friction in the troubleshooting. What about making sure that things stay fast, that certain things don't introduce regressions to the build toolchain, right? We've seen everything from endpoint security slowdown builds to new annotation processor versions that get introduced. All of a sudden, the build takes twice as long. If you're not tracking that, your developers are just going to say, oh, the build's taking twice as long as it used to. That sucks. And then they'll just go on and deal with that toil. It's actually staggering the amount of friction and toil that engineers are willing to put up with, I think. But it's up to us to make sure that they don't have to. So again, without focus, problems can sneak right back in to the build tool chain. So we would want to encourage continuous improvement and continuous performance then through these observability technologies. So flaky tests and flaky test detection. This is actually a Spotify quote. Spotify calls flaky tests the infinite pit of sorrow because of the amount of toil that they cause in multiple directions, right? They're confusing to developers. If you're working on a predictive model for testing like ours, flaky tests will taint the training data, right? And then on top of that, it's really hard to troubleshoot these things. And finally, what usually happens when a developer's like, oh, test failed. Oh, it succeeded on this run. Great, I'll just kick it down the road. Nothing happened. I'm sure it was fine. Right? Spotify can tell you that pretty much any jankiness that you find in their app can be traced back now to a flaky test of some sort. So analyze these things, right? If you're able to cache inputs against a specific set of data, what else can you do? Well, you can compare test tasks. And you can say, okay, under the exact same conditions, this test passed, and then it failed. And then it passed again, then it failed. I think it's flaky. And then put it on a dashboard. People can deal with it. Same with the failure analytics, right? Common failures that are happening across the organization, aggregate them, bubble them up, put them in a dashboard so they can be dealt with. And then trends and insights. Again, make sure that you're watching this stuff not just once, but that you're watching it over time. And then finally, machine learning can help us lead to greater efficiencies here. So predictive test selection, really a powerful machine learning innovation, which is nice to see in this space, right? It's solving a real problem. It's not just machine learning for the sake of machine learning, right? This is actually, in some cases, like cutting tests, like test sets down from like 20,000 tests to like 10. If you really look at what needs to be run based on small change sets. It just looks at historical code changes and characteristics to accurately predict which tests are interesting or likely to fail. There's lots of different ways to build this. Facebook's paper in 2019 recommends not using deep learning. That way you don't have to install a GPU or anything like that. But you can actually do just fine with test selection using a gradient-boosted machine learning model, or even multivariate analysis, depending on how comprehensive you want this to be. So with all this, I think the DPE is going to become standard practice because the world really should foster developer joy, especially now. And that's what this is all about, engineering a better experience for developers. Organizations who do this best, they build their own central team. So these are just a few examples. And again, this is all within the last 5 years. Okay, this is not like Netflix has had this around for a while. They built their productivity team in 2018. But also you see Spotify having a central team, LinkedIn having a central team, SoundCloud central team, the Elastic Group central team. All of these organizations have built center of excellences that just focus on developer productivity. They look at metrics and things like I've described to you today. They centralize it, and they have people who are focused on just cascading better practices based on that to the rest of the organization. If you want to learn more about this practice, we do have a whole learning center on it that's available to you. Again, I would kind of encourage you, if this has been interesting, just put yourself in the shoes of that person 5 years ago who brings DevOps practices in the organization, who really fights and scraps for those practices to get put in place. Now, of course, when they're in place, 2 weeks later, nobody ever remembers anything being any different, but those people are heroes in the organization. You can be too. And if the Learning Center isn't necessarily what you're after and you'd rather see like a whole handbook about how all this stuff works, we have that. It's an 81-page vendorless handbook on developer productivity engineering. You see Gradle on the front, and that's the only logo you'll see in the entire thing. This is meant to be, really just the practice of building a developer productivity organization within your business. And that's it. Thank you so much. I really appreciate it. I hope this was interesting. We do have, I think, a couple of minutes for questions.
We have some time for a few questions.
Sure, absolutely. Oh, thanks.
So do we have any questions? You can just raise your hand, and then we have a mic coming up to you.
Don't be shy. Oh, there we go.
Yeah, we have one in the front. We have Andy doing a sprint all the way from the back.
Is it a cat?
Please raise your hand again. Yes.
Hi.
Can you talk a little bit about the differences between the developer experience and developer productivity? Do they relate, or are they different fields? Or?
I think they're very much related. So I think that developer productivity engineering leads to a better developer experience, right? That's absolutely the value. If we were to start with kind of why developer productivity engineering, it really goes back to that whole 65% global GDP digitally transformed. And what does that lead to? Imagine if every software company, which is every company now, was able to innovate at 10 times the click that they're innovating. 10 times. If everybody could be a 10x developer, so to speak, right? What does that do to the world, to the pace of innovation, right? But it all starts with a better developer experience, right? It all starts with developers really having the tools they need to just focus on their work, and not context switching, and not being frustrated by having tools that introduce friction and make it more difficult to do their job. So I think that what we're arguing here in developer productivity engineering is that a better developer experience naturally leads to increased developer productivity. Make sense? Yeah.
Any other questions?
Yep.
Yeah, we have one in the back.
Just a quick one.
Sure.
When the entire team consists of like 10 people, do you have any kind of hints on how you'd implement DPE rather than organizations of size like Google, Meta, whatever?
I think so, but I think I would still stick by what I said before, that developer productivity engineering isn't just for big Silicon Valley companies. It's really for anybody who's developing software. In terms of how those strategies might differ a little bit, though, well, like looking at a remote cache, for instance, right? If you've got 10 developers, probably one single remote cache node that everybody's sharing, not even necessarily plugged into CI, is going to be okay for you. If you've got 3,000 developers working on 300,000 builds a day, like LinkedIn has, then you're going to have a bunch of remote cache nodes, and we're going to have to be able to, administer them all and deploy them easily and make sure that they scale, right? But at the end of the day, I think because this is an engineering problem that we're solving, because we're using technology to solve this, it scales really from small teams to large teams, just like any other technology would scale. So the process of it, the mindset, I really think for a team of 10 or even smaller, the mindset will pay off, and actually putting this stuff in place will pay off. Does it pay off at a much greater scale if you've got 3,000 developers and 300,000 builds a day? Yeah, of course it will. Yeah, of course it will. You've got a much more expensive cost center there developing your software. But I do really stand by the fact that this is for everybody. Anything else?
I think that was what we had time for this round. So thank you so much.
Oh, my pleasure. Thanks, everybody.
Give him another round of applause.
Thanks, all.